Salam and welcome everyone to my channel. Today we're going to be working on the question on the screen that says at 500 degrees Celsius and 93.2 kilopascal, the mass density of sulfur vapor is 3.710 kilogram per meter cube. What is the molecular formula of sulfur under these conditions? So the first thing you have to do is to write out the parameters. We've been given the temperature in this question to be 500 degrees Celsius, which is the same thing as temperature equals 500 plus 273.15. So we can basically go from degrees Celsius to Kelvin to get 773.15 Kelvin, and we're given pressure to be 93.2 kilopascal, and this will stay the way it is. And we're also given mass density, which is just simply density, to be 3.710 kilogram per meter cubed. So we're now asked to find the molecular formula of sulfur under these conditions. So the first thing we have to do is to remember that this question is taking the form of a perfect gas. Hence, we're going to use the perfect gas equation PV equals nRT. So from this, you can see that we've been given the pressure, we've been given the temperature, but we've not been given the volume, neither have we been given the number of moles. But we also know the gas constant, because since it's a constant, we always know the value. So depending on how the question is, we can either use 0.08206 or 8.3145. And I'm not going to write the units for both of them, because depending on what the question is, the units would vary, but they have to be these two values no matter what. So this is just something I just feel like I should put on the side. But we have like two unknowns in our question. And one thing about solving in chemistry, math, or just doing calculations, you can't have two unknowns. It messes up the question. But we also know that we've been given another parameter, which is density. And just remembering basic physics, chemistry, or basic science, we know that density equals mass over volume. So therefore, we have a volume right here, and we would write this volume that we have right here in terms of mass and density. And to do that, we end up getting volume equals mass divided by density. So we're going to substitute this volume here. And then we also have N, which is number of moles. And we also know that number of moles is the same thing as mass over molar mass. So we have the molar mass, we have the mass, and we write that in terms of number of moles. So we don't have to do any recalculation here. So next thing we do is just substitute the information. So we have P times V in terms of mass and density. So that would be M divided by D equals number of moles in terms of mass and molar mass. That will be mass divided by molar mass. And then we have R, and then we have T. So we cancel out mass, we cancel out mass. What we end up with is P divided by D equals RT divided by molar mass, or mm. Now, if we look at the question, we see that we've got the pressure, okay, we've got the density, okay, we know the gas constant, okay, and we've got temperature, but we don't have molar mass, which works for us because we have five parameters in total. We have four known parameters, like the values of four parameters, and we have one unknown, meaning we're going to be solving for the molar mass mm. So that would just mean rewriting all of this equation. P over D equals RT, RT divided by molar mass. Rewriting this equation in terms of molar mass, we're going to end up having RTD divided by P. So basically, the gas constant times the temperature times density, all of that information divided by pressure. And we're going to now input the parameters for each one of them. We're going to input the parameter for pressure, for density, for temperature, as well as the gas constant that works well for this question. But before we go on to do that, we have to break the information down. You see that the density, which is 3.710 kilogram per meter cubed. We see that it is in kilogram. We know that molar mass in chemistry is usually gram per mole. And basically, majority of the calculations of math in chemistry, if not all of them, majority actually, not all of them, they tend to work with grams. They don't work with kilograms. So that is teaching us that because of we're doing chemistry, we have to convert from kilograms to grams. That's the first thing you have to know. Then secondly, we have meter cubed, and We can leave our information in meter cube, but what is more common in chemistry is to have dm cube instead of meter cube, because it's just easy for calculation, and it's more common to have dm cube instead of meter cube. So what this is teaching us now is that we have to go from having kilogram per meter cubed, right? Per meter cube to gram per dm cubed, or you can also say gram per liter, because dm cubed, right, is the same thing as liter, right? Dm cubed is literally the same thing as liter. It's just that dm cubed is used more in the UK, and then liter is used in the US. So depending on what curriculum you are using, you can see that some places are going to use dm cube, some other places would rather use liters. So just put that in your memory. So now we're going to change the units of the value of density. So we've got 3.710 kilogram per meter cubed. And we're going to try to use dimensional analysis to change it to gram per liter or gram per dm cube. So we know that kilogram will be at the bottom and grams will be at the top. So we have to remember that 1 kilogram always gives us 1,000 grams times, we're going to have the meter cube up top and we're going to have the dm cube at the bottom. And we know that 1 meter cube always gives us 1,000 dm cube. And the way you do it is just remembering that 1 meter equals 10 decimeter. Hence, 1 meter cubed, which is 1 times 1, which is 1, and meter times meter, which is meter cubed. The same way, you're going to have this 10 decimeter, all of that information cube, which is just going to be 10 times 10 times 10, which is just 1,000, and dm times dm times dm, which is dm cubed. So that's how we have 1 meter cube equals 1 decimeter cubed. If that makes any sense. I believe it does. So that's the thing you have to know. And that is it. Like, that is literally it. So we go on to cancel out the kilograms and cancel out the meter cubed. And what you end up with is gram per decimeter cube. But the thing now is we have a 1,000 up top, we have a 1,000 at the bottom. So we just simply cancel that out and we write the new unit conversion of the value to be 3.710 gram per decimeter cubed, or 3.710 gram per liter. So that is how it's done. So that is what we're going to use now to that's basically what we're going to do now. So yeah, now we've done 3.710 gram per liter. Now we can input this information into the question, sorry, into the equation at above. So RTD is the same thing as having 8.3145 K, which, and we have the kilopascal liters divided by mole Kelvin. That is the unit for the gas constant. And you've got temperature to be 773.15 Kelvin times the density to be 3.710 gram per liter. All of that information divided by the pressure, 93.2 kilopascal. So we're going to cancel out the liters. We're going to cancel out um, the Kelvin, and we're going to cancel out the kilopascal. And what we're going to end up with is just having the gram right here and the mole right here. So let me just rewrite everything. Molar mass equals, just rewriting anything that hasn't been canceled out so everyone understands. So you have 8.3145 times 773.15 times 3.710 divided by 93.2, and then you have gram per mole, because of course we want the molar mass to be in gram per mole. So we input all of this information into a calculator to get 255.893 gram per mole. Now, the question asks us to find the molecular formula of sulfur under these conditions. Molecular formula is of sulfur is just telling us that sulfur has more than one atom. Hence, sulfur is a molecule. So sulfur could end up with 2 atoms. Sulfur could be 6 atoms. Sulfur could be 12 atoms. They want us to be able to write the answer in this form, where we're going to be dealing with the sulfur as a molecule, but it needs to have a formula. Now, the way you're going to do that basically is for you to use the information with sulfur. we see that the molecular mass is 255.893 gram per mole, then we have to remember that this is just the molecular mass of sulfur. We have to remember that sulfur itself is an atom, right? And the atomic mass for sulfur, meaning one sulfur's atomic mass, an atom, which is one, molecule, which is more than one, right? The atomic mass of sulfur, we have to go onto our periodic table. And when you check it, you're going to see that it is 32.065 gram per mole. So the molecular formula is just going to be the unit, basically the unit of the molecular formula is going to be the molar mass divided by the atomic mass. So you have 255.893 gram per mole divided by 32.065 gram per mole. So you cancel out the gram per mole, cancel out the gram per mole. So you have the molecular formula unit basically to be 7.98, and 7.98 approximately when you're dealing with units is just 8. So the sulfur atom or the sulfur molecule is just going to be S8. So basically, in this molecule of sulfur, there are 8 atoms of sulfur in this S8 molecule. So that is the molecular formula. The molecular formula is S8. Wish you guys all the very best. If you have any questions, please put it in the comment section. If you want personalized tutoring or group tutoring for all your STEM classes, whether you're in middle school, high school, or college level, make sure you email me at shuhabitutoring@gmail.com. Again, shuhabitutoring@gmail.com, and just say you want to talk to Habiba, and I'll be there to schedule a tutoring session with you, or actually make a tutoring plan, which I'm also a mentor for students who need help and guide through your schoolwork or through their basically your academic year. Okay, I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.